Welcome you my lecture series of data structures. In last video we have seen how to find the minimum spanning tree using the Prim's algorithm. In today's video we are seeing about how to find the minimum spanning tree using the Kruskal's algorithm. Already you know that what is a minimum spanning tree means. So the minimum spanning tree is a spanning tree that than all other spanning tree of minimum weight. So in the Kruskal's algorithm, in the Prim's algorithm, how do you find the minimum spanning tree means select any random vertex, from that vertex find the adjacent vertices, and from that adjacent vertices which one vertices weight is very minimum means go to that vertex and repeat the process until we visited all the vertices. So finally we get the minimum cost of the given tree. So next using that Kruskal's algorithm, how do you find out that minimum spanning tree means first sort all the edges from the low weight to high. So in the given graph sort all the edges from low weight to high. Second, now take the edge with the lowest weight and add it to the spanning tree. If the edge to be added, create the cycle, then reject the edge. The second step, take the edge with the lowest weight and add it to the spanning tree. If the edge is to be added, create the any cycle means, then reject that edge. Continue to add the edges until we reach all the vertices and the minimum spanning tree is created. And from that minimum spanning tree, find the minimum cost. For a given graph, the above graph contains that 6 vertices. So first step means what is the minimum spanning tree means it should be the connected vertices and it should not form the cycle. So from the given graph, first step we sort all the edges from low to high. First the minimum weight is 1. Minimum weight is 1. So add D comma E 1. Next is at 2. So B comma D 2. Next is an A comma B. So the third column fill that A comma B is 2. So next to minimum weight is 3. So A comma C is 3 and C comma E is 3. So add that tongue. Then again D comma F is also 3. So add D comma F 3. Next to minimum weight is 4. So C comma D is equal to 4. And next is E comma F is 5 and B comma C is 6. So totally we have a 9 edges. So add the 9 edges along with the weight from low to height. First step, from that 9 edges take the lowest weight and add the edge to the given tree. ஃபஸ்ட்டு ஸ்டெப் வந்து நம்ம என்ன பண்ணிக்கிறோம்னா எல்லா எட்ஜஸும் நம்ம மார்க் பண்ணி வச்சுக்கிறோம். எல்லா வெர்டிசஸும் மார்க் பண்ணிக்கிட்டு அதில் எது மினிமமோ அதை we are selecting. So D comma E you create the edge to the given tree. Next minimum is A comma B. Suppose we are going to create a edge means first we have to check that edge form the cycle. If it is meant reject that edge, otherwise we draw the and connect that edge. Next minimum is 2. So A comma B 2. Next is B comma D. So again B comma D. Check there is a cycle is formed. No. So connect B comma D. Next A comma C. So there is no cycle is formed. So add the vertex A comma C. Suppose C comma E mean that form the cycle. So reject that edge. Next is the D comma F. D comma F, once you join the D comma F, it does not create a cycle. So add the vertices in the given tree. Next C comma D means C comma D, it is formed the cycle. Next E comma F, again it formed the cycle, and B comma C, again it formed the cycle. Now you find the given graph whether all the vertices are connected and it should not form the any cycle. So this is the minimum spanning tree of the given graph. So what is the cost of that? The cost of the graph is 5 and 5, that is 11. So the weight of the given minimum spanning tree is 11. So one thing we should consider, one thing we notice that, so the minimum cost of either we find the prims or Kruskal's, the cost value should be equal. So procedure is different, but the final output and graph and weight is also all are same in the prims and Kruskal's algorithm. So in the Kruskal's algorithm, sort all the edges from low to height and add the edge from the low to height, low to high value. Whether in the terms of adding it create any cycle means reject the edge, otherwise you continue the process until we visited all the vertices. I hope you will understand what is the Kruskal algorithm to find the minimum spanning tree of the given tree.